So in this video we are going to discuss about Cascode amplifier. So this amplifier is used in RF applications like video amplifier, and it consists of CE stage, C, that is common emitter stage, followed by common base stage. Okay, so here the common emitter stage, and it is directly coupled. Okay, so it is directly coupled. So it combines some features of both the transistor. That is, if you see in the common base amplifier, it is having a very low input impedance. Therefore, at the input stage we are connecting a CE stage which is having a very high input impedance. So since it is directly coupled, the Miller effect can be avoided. There is no Miller effect. Okay, so therefore we can able to achieve a better bandwidth, and it can also provide a very good isolation between the input and the output. So this will provide a very good isolation between the input and output. So first let us draw the circuit diagram. Okay, so here you have so this is nothing but a common emitter amplifier. So this R1 so this R1, R2 and RE are your biasing resistance, and this is your common emitter stage, and so here I have one capacitance. So this is your coupling capacitance, and these are your input resistance. Okay, input resistance and voltage source, input voltage source. So this has to be connected to the common base. Okay, so common base means so the input is emitter, and so this is also having a one biasing resistance. Let me term that one as R3 and R4. Okay, so here you have one coupling capacitance, that is C2, and since it is a common base, the base terminal is grounded. So this is your output collector resistance RL. Let me term that one as RL. Okay, so here only you are taking the output with respect to the emitter. So this is your transistor Q1 and Q2. Okay, so for AC analysis, for AC analysis. DC supply must be grounded, and capacitor is short circuited. So therefore I am going to redraw this one as VS RS. Okay, so this is short circuited, and this terminal, this is RB is nothing but R1 in parallel with R2. Okay, so after that it should be connected to my this, since it is a common emitter, base is here, so you have HIE of 1 first transistor, and this is your emitter terminal, and here you have a HFE1 of IB1, right? So the current flowing through this one is IB1. So since the capacitor is short circuited, the emitter resistance is avoided. Okay, so next this collector is connected to the emitter of the Q2 transistor. So here it is connected to the emitter of the, so this is the emitter of the first transistor that is connected to the emitter of the second transistor. Okay, so this entire circuit is nothing but your common base stage. Okay, so consider I'm going to take this entire circuit. Okay, so here what I am going to do is this is your emitter and this is your base, since the base is common, and this is your collector. Okay, so you can see so this is the collector. So from collector to emitter you have one current terminal, right? Current source. So I am going to connect it like this. This is nothing but HFE2 of IB2. Okay, and from emitter, from base to emitter you have one resistance. So I can write it like this. This is nothing but HIE2. So the current is flowing from base to emitter. So the base to emitter current is IB2. Okay, so you can see from collector it is connected to the emitter, right? From the collector it is connected to the emitter. So this is your collector terminal that is connected to the emitter of the second transistor, second transistor, and the emitter of the second transistor is connected to the collector of the first transistor. And since this is grounded, the collector of the second transistor RL must be connected to the ground. Okay, so here you have a RL. So let me term this current as IS, okay, and this is IB1 and this current as IC1 and this current as IE2, okay, and this current as IC2 and this current as I0. I0 is your output current, okay. So let me take the common emitter stage. For common emitter stage, we know that AV. What is AV? AV is nothing but AI RL divided by RI. So we know that what is the value of AI? AI is nothing but minus HFE, HFE of 1. What is RI? RI is nothing but so this is your RI, okay. So this your input voltage. So the resistance of input resistance is nothing but HIE1. Okay. So what is RL? So output resistance here is nothing but the input resistance of so this is your VI let me term this is VA of this stage, and this is your VA of the common base stage, okay. So RL is nothing but RI2, okay, RI2 of this one. So how to determine the value of RI2? So RI2, so here my RI2 is nothing but VE divided by IE. So for the second stage, your input voltage and output voltage is emitter. So I can write V is equal to minus IB2 into HIE2 divided by IE2. IE2 is nothing but IE2 is nothing but the incoming current IE2 plus HFE2 IB2, IE2 plus HFE IB2 plus IB2 is equal to 0, right? So I can write IE2 is equal to minus IB2, I can take it as common, so 1 plus HFE2. So you substitute here minus IB2 into 1 plus HFE2. So you will get IB2 cancel, minus get cancelled out. So here you will get RI2 is equal to HIE2 divided by 1 plus beta. 1 plus here beta represent HFE2. So this is nothing but your HIB. So we know that AV is equal to minus HFE RI2. This is your RL term, right? This is your RL divided by RI1. RI1 is nothing but HIE1. Okay. So next let me go for the common base stage. So I am doing the similar thing. We know that AV is equal to AI RL divided by RI. So here AI is nothing but minus HFE2, and what is RL? RL is nothing but your RC. Next I need to find the value of RI2, right? So RI2 I have already found out, right? RI2 Re2 value I have already found out, and RL value is RC. Okay, next I need to find the value of AI. AI is nothing but output current by input current, right? So I naught divided by IE. Okay, IE2. So this is nothing but minus IC2 divided by IE2. Sorry. A is nothing but IC2 divided by IE2. Okay. So here from the diagram I know the IC2 value. IC2 value is nothing but HFE2 IB2. And IE2 value I know. IE2 value, what is IE2 value? IE2 value is IB2 plus 1 plus HFEB. 1 plus HFE2 into IB2. Okay. So A is nothing but I naught divided by IE2. So this is your minus. So here minus. So if I solve this one, I will get A is equal to HFE2 divided by 1 plus HFE2. Okay. And RL value is RC, and RI2 value I know that this is HIP. Okay. So if I want to find the value of AVS, okay, so if I want to find the value of AVS, means AVS is nothing but VS by this value, right? So this is your AV. So up to this one I have find out the value of AV. So what is VS? AVS is nothing but AV into RB divided by RB plus RS. Okay. In a similar way, if I want to find the value of AIS, okay, AIS nothing but I naught divided by IS. So this I can write it as I naught divided by IC2 into IC2 divided by IE2 into IE2 divided by IC1 into IC1 divided by IC1 divided by IB1 into IB1 divided by IS. So we know that this is nothing but minus IC2 divided by IC2, right? You know that the I naught current is opposite to that of IC2. Okay. And what is IC2 by IE2? IC2 by IE2 is nothing but IE2, AI2, and IE2 and IE2 and IC1 are opposite in direction. You can see here from this equation, IE2 is equal to minus IC1. Okay. So I can substitute this one, minus IC1 divided by IC1. So this is nothing but IC1 divided by IB1 is AI1, and what is IB1 divided by IS? So So my is nothing but IB1 into the opposite resistance. Opposite resistance is RB, right? RB divided by RB plus HIE1, right? So I can write IS divided by IB1 is equal to RB divided by RB plus HIE1. So you substitute RB divided by RB plus HIE1. So on solving this 2 get cancelled out, so I get AI2 into AI1 into RB divided by RB plus HIE1. So I hope this video is useful for you. Thank you very much.